Another thing that is typical to this formulation is the quality by design. Quality by design is today inside the guideline for formulators, which means for pharmaceutical companies. So they use it, and they kind of expect to see it in the API file as well, although it is not yet mandatory for API makers. But here, more than in any other case, they will ask for quality by design. Quality by design is an approach required by the FDA for the manufacturing of the drug product, but more and more for the drug substance as well, especially for the micronization step. There are two main aspects for quality by design when we go to the practice. First of all, validating the edges of the specs and the operating parameters, which means that if your specification is 1.4 to 2.6 microns, you want to submit 2 batches in this particle size to show that they are okay. And second is to show linearity and controllability of the process parameters. Often using the design of experiment approach means that if you micronize material and you're using air pressure, what happens if the air pressure go up or down, let's say by half a bar? How does it affect the particle size? Show me that you can control the particle size very accurately by knowing exactly what air pressure to use. Now, you all do it as part of validation, but you don't always submit it to your clients. And so how do we do it and submit it to the clients correctly? Let's start with the formulation. In many cases, the formulators will ask you for samples with very specific properties, typically at the edges of the PSD specs. They will ask you, okay, I want a very small sample with very accurate particle size and also the one in the higher than that, and that's in order to validate the formulator's process. You should treat these samples very seriously, although sometimes they are very small, and make them very accurately with GMP and all the documentation, because these samples may be included in the file, even if they are not commercial yet. So this is QBD on the formulator side. When it comes to QBD on the micronization process, it will ask you for kind of a validation report, of course, but they would expect to see these analysis of the edges of parameters and the linearity. So for most micronizer, I would go for something like this. I would choose, let's say I know more or less what is the center of my parameters. I would go for I will check grinding pressure and feed rate. It's not that complicated. Of course, there are many more, much more complicated processes, but let's say we are focusing on feed rate and grinding pressure. Then for the medium feed rate, I would check high, low, and medium grind pressures. For the medium grinding pressure, I would check low, medium, and high feed rate. When I say low and high, is more or less to validate the edges of the specs, okay? And then I would also check the extreme conditions, the low feed rate and high pressure, which is the smaller particles, and the high feed rate and low pressure, which is the largest particles. And if you build this matrix correctly and you get reasonable results, then you have a very good validation report. I'm sorry. This is the do's and don'ts. When you are approaching a API formulation, either if it's a steroid or one of these bond hole dilators, and more of them are becoming generic now and more companies are doing them, you should look at this at a different way than you look at normal APIs. And you may even want to have a specific crystallization and manufacturing process just for this. For example, if you have one steroid that goes for traditional tablets, and you have also this steroid for inhalation, treat the inhalation product differently. So I'll start the crystallization. In many companies, they say, okay, I need to get 2 microns. I want the micronization process to be efficient. I don't want to micronize 20 times. Let's do the crystals very small. So they designed the crystallization process to produce small particles. I even saw cases where you take the standard product and you recrystallize it in conditions just to make the small particles. I think this is not the right approach for inhalation products. And why is that? When you crystallize particles and you design your process to produce small particles, it means that you are on the edge of the crystallization curve, which means that you have a lot of seeding and less of a growth of the particles, and it means that your particles are less crystalline and less perfect and less uniform. On top of that, since you are centrifugating them, you filter them and you dry them, then to filter and dry small particles is less efficient, and again, you get an inferior product. And in the end of the day, your micronizer doesn't care too much if it starts from 50 micron particles or 30 micron particles, okay? In fact, sometimes if you have nice, large and brittle crystals, which means with high level of crystallinity, it will be easier for the micronizer to handle, and the product will be better. If you start with particles that were crystallized to produce small, not uniform, poor morphology particles, you're not helping the micronization process. So I would recommend to aim for large, high crystallinity particles and not for easy to micronize particles. The second approach would be to acquire technology for achieving the particle size distribution in one pass. And this is where I mentioned Superfine. Superfine has the micronizer that work on a different principle than normal jet mills. And we checked many of these bond hole dilators and corticosteroids that are used for inhalation. We made them for many applications, also commercial, and always this micronizer can take it in one shot. And once you can micronize your product in one pass, you save a lot of manufacturing issues, because the second micronization is not efficient. You lose material. You have this issue of residence time. You lose a lot of time. The feeding is not uniform, and you also save a lot of questions from the FDA and from your client. So, if I would recommend to invest in anything in this, is to invest in a technology that can make this micronization in one pass. It is true for every product. I would say that generally, if more than 10% of your products need to be micronized more than once, you have a problem with your micronizer, okay? If you see that consistently more of your products are going under more than one micronization pass, you may want to check your technology. Maybe it's time to upgrade your micronizer, or at least fix them. But when it comes to respiratory, it has also to do with real quality and regulatory issues. The second recommendation is to stay in the low scale. Usually these products for inhalation, the doses are in micrograms, and your batch size is usually less than 100 kilograms, maybe 40, 50 kilograms. And I would not recommend to put this in a huge micronizer because it's difficult to control. You have more losses. Also not in a very small micronizer. I know that some clients are doing it, or some companies are doing it in 50 millimeter micronizer. It's very small. I would stay between 100 and 200 millimeter micronizers. And there is also another consideration. It is easier to put them in a glove box, okay? 100 millimeter micronizer is easy to put in a glove box. 200 millimeters, so. It's already start to be a split glove box, which is more expensive, and above that, it doesn't make sense. So, since these are potent products, you want to stay in the low scale. Again, I will mention Superfine that can make in a the micronization itself, the micronizer is very compact, so you can put the capacity of a normal jet mill of 200 millimeters into a small glove box. So that's another advantage. But stay in the low scale. Another thing is control feed rate. Feed rate is always important, especially micronization of respiratory products. Now, in most cases, of course, you need to calibrate the feed rate in every batch. That's a general recommendation that I make. Always in every batch, you need to do the calibration. Your feed rate in the batch card should be in kilograms per hour, okay, not in RPM of the feeder. Always kilogram per hour, and you need to calibrate the feeder in every batch, because batches every batch has a different density and different flowability. Usually, in most micronization processes, you don't need a gravimetric feeding, but if your micronizer is not accurate, you may want to consider gravimetric feeding, which means that a feeder that controls the gravity, the feed rate all the time. It's more expensive, it's complicated, but in this case, it may justify the investment. Sometimes the specifications that you need are so narrow that the normal variations of the micronizer are not good enough. And even if your process is stable, the particle size specification is not narrow enough. And then you would consider either at-line or in-line PSD analysis. A bit about both. In-line means that you have like a laser diffraction apparatus sitting inside your micronizer or inside the external tube, and it watches the particle size online all the time, and maybe it even corrects the feed rate during the process real time. It's very complicated, it's expensive, it is difficult to install. If you have a dedicated line just for a respiratory and it's very big and very important, you may want to consider that. A more simple approach is at-line, which is an automated particle size analyzer, which is in the production floor. It doesn't sit inside the micronizer, but you like take a sample and you every few minutes, you just take a sample and put it there. You don't wait for QC results, and then you have real-time results. And this is a more reasonable approach. And the last thing about containment, we will have a different session about containment, glove boxes, split valves, all these things with our containment partners. So I will mention here only one thing: avoid complicated equipment. Don't use intermediate tanks and filters, and try to keep it very simple, I would say almost primitive. And once you're inside the glove box, put an emphasis on ergonometry and cleanability, because these are the important things to make the process smooth, to make sure your workers don't do shortcuts by like opening the glove box in the middle. And of course that it is easy to clean between batches. Okay, I think I kept it short and we have time for questions.